Hello, good evening everyone, good evening and welcome to another most beautiful, marvelous session of 90 plus my tuition app. Are you ready to begin the session? Are you ready for that? Yeah, no one is like, no ma'am, we are not ready. Is it? Are you ready for the class? Yeah, say it loud. We are ready ma'am, we are ready for this class. Yeah, I'm asking again, are you ready? Yes, I can see the beautiful thumbs ups. Very good, very good. So here we go, the chapter Matter in Our Surroundings. So before that, let me ask, how was the Eid celebration? How was it? Did you spend the time well? How was the Eid? How are you? I'm doing great, I'm doing great. Yeah, it was good. And how was your Eid? Yeah, I celebrated a lot, eaten well. Yeah, that was a good time. Fantastic, great. And Eid was good, ma'am. Very good. Good to hear that. Ma'am, unmute one for me.
Okay, let's ask Ethan.
Ethan.
Oh.
Ethan? Not able to unmute? Yes, how are you, Ethan?
Fine, ma'am.
Fine. So, what about the Eid?
I went out like 2 times with my family.
2 times with the family? Yeah, that was a great moment, right?
Yes, ma'am.
Yeah, very good. Good to hear that. I hope everyone is doing great and celebrated well. And we are back with the studies, right? And we have to complete the chapter. Maybe not today, but soon we will complete it, okay? And here we go with the chapter Matter in Our Surroundings. So, do you remember everything from the last session? Or just forget everything with the holidays and the celebrations? Isn't it? Yeah, literally forgotten everything, ma'am. We don't really remember anything. Is it like that? No, right? No, cannot be. You remember everything. So I'm going to ask the questions. And before that, do you remember something about the impositions? Yeah. The first one, ma'am. Rishikesh, right?
Yes.
Rishikesh was so surprised. Oh, I totally forgot about the impositions, right, Rishikesh? Only Hannah sent me the impositions. Am I right? Yeah, Hannah. Only Hannah, I think. And what about Grisha, Rishikesh?
Grisha is saying that she did that.
Oh, Grisha sent it me. What about Hannah then? Yeah, I'm just confused with the names. Rishikesh. Where's the imposition, Rishikesh?
Actually, he's
Yes. Tell me, where's the imposition?
Imposition.
Yes, impositions. You heard the right thing. Yes, impositions. Yeah, give me some valuable reasons.
Solid liquid gas.
Yes. Yeah, I'm not talking about the states of matter. Now I'm talking about the imposition that I gave you. Where is it? Do you want me to double it? No answers. All right. I'm telling you for your sake, not for me. Okay. If you want to study, you can write it and learn it. Okay. I'm not compelling anyone to do anything. If you want to study, you can, and I will help to study those things. Okay. That's all I can do, and I can motivate you. Yes, you can do it. And if you want to get motivated, you can. If you don't want to get motivated or don't want to study, it's perfectly your choice. Okay. So moving towards our chapter,
teacher,
matter in our surroundings. Yeah.
Hand raise. Abid.
Hand rise. Who's that?
Abid.
Abid. Yes, Abid. Abid? Chemical formula for what?
Don't permanganate.
What permanganate? Potassium permanganate?
Yeah, potassium.
Yeah, it is KMNO4. It is KMNO4, okay? KMNO4. Yeah, here. KMNO4. Potassium permanganate. Okay. Alright, very good. So in the previous session, we learned about fusion or melting and about the melting point. Now unmute one and ask, what is exactly melting? Let me check how many of you remember the things. Yes. What is melting? What is melting? Hand rises. Very good. Good to see that.
Yes. Let's ask.
Hi, ma'am. I'm able to see the others. Searching.
Okay, let's unmute
Ah.
Umaima.
Umaima. Yes, Umaima. You can tell me what exactly is melting.
Melting and melting point is a temperature at which
Yeah,
a
not the
solid starts to melt. It's converting into liquid. It's
Yes.
called melting.
Yeah, that is melting point. What about melting?
Melting. It's the temperature at which it starts to become a liquid.
That is melting point. Now what is melting?
From when the matter changes, the state changes from solid to liquid.
Yes, that's it. The change of state of matter from solid to liquid at a specific temperature and pressure is called as melting. And she already told that what is melting point? It is the temperature at which a solid converts into liquid. At that point or the particular temperature is called as the melting point. So the melting point, boiling point, everything, the point, the thing that comes with a point refers to temperature. Okay, don't ever forget that. It refers to temperature and don't ever skip the part temperature over there. You will lose mark definitely. So it is the temperature at which a solid changes from solid state to liquid state is called as a melting point. Now the next one was boiling, right? Boiling and the boiling point. Now tell me what is boiling? What is boiling? Ma'am, unmute one for me. Yeah.
Let's unmute Famita.
Famita. Yes, Famita. What is melting? I'm sorry. Boiling. Melting is already done.
The change of liquid state to gaseous state at the specific temperature and pressure is called boiling.
Very good. That's it. That's it. Liquid state into gaseous state at a specific temperature and pressure is called as boiling. And what exactly is boiling point now? Unmute and someone else.
Okay,
ma'am.
John. Yes,
John. John, now tell me what is boiling point?
Ma'am, I know boiling point is, but I am raising hand because I wanted to tell you that I wasn't there for the last class.
You weren't there in the last class?
I think on the 17th was the last class, which I did not attend.
17th was the last class, I guess. Yeah. So you were not there.
No.
So the things boiling and boiling point, you don't know those things, right?
I think boiling point is the maximum point of which a liquid can be heated.
Yeah, I have told you the boiling point, melting point refers to the temperature. Okay, they are all refers to the temperature. So you have to mention like the temperature at which a liquid state converts into gaseous state is called as its boiling point. Okay. That's it. So the temperature at which a liquid start to boil and convert into gas is called as the boiling point. We already discussed those things. That's why I'm going a bit faster because we have to complete the rest of the things. Okay. So boiling and boiling point. You can take a screenshot and write it later. Okay. Who was that man?
Which one?
The one we called now, just now. Yeah.
John.
I have memory problems. I just
John.
forgot. Not John.
John.
Just we called just now, right? It was John?
Yes.
Yeah.
John.
Alright. John, take a screenshot and write it later, okay? Yes, fine. And here we go with the next one, sublimation. Sublimation was the next one, okay? Sublimation. Now who is going to tell me what is sublimation? Sublimation. Unmute one for me, man.
Okay, that's unmute. Anika.
Aneka. Umaima have beautiful mehendi design in her hand. I like it, Umaima. And I also have that, but it literally faded. See? It's already faded. Yeah. Yes. Who was that, man?
Anika.
Aneka. Yes, Aneka. What is
Can you hear me?
sublimation?
Ma'am, can you hear me?
Yes, I can.
Ma'am, sublimation is the change of state of matter
Mm.
from which a solid changes into gaseous state
Ah.
without going to the liquid state.
Very good. That's it. Without passing into the liquid state, they just convert directly from solid state into gaseous state is called as a sublimation. So change of state of matter from solid state directly into the gaseous state without passing into the liquid state at specific temperature and pressure is called as a sublimation. And what about the examples? What about the
Ma'am,
examples? Yes, ma'am.
There is a request
Down?
for the previous slide.
Previous slide? Definitely. So, can you turn off the transitions? Yeah.
Yes.
Yes. Here we go. Done? Done. Dry ice is an example. Definitely. No one will forget about the dry ice, right? We have discussed a lot about dry ice in the previous session. So, no one will forget the dry ice. And what else? What else? Say the transitions. What else? What are the examples? What are the other examples that you can give for sublimation? Here we go. Naphthalene, camphor, iodine and ammonium chloride and definitely our dry ice all are example for the sublimation because they all just convert directly from solid to gaseous state. Right? Naphthalene balls, the most common example that we see in our daily life. If we keep some naphthalene balls, after a few days, we cannot see it because it just converted into gaseous state and escaped from that, right? Escaped into the air. So, that's about the sublimation. So, these are the things that we have already discussed in the previous session. Now, going towards today's session. Ready for that? Yeah, take a deep breath now. Take a deep breath. Yeah, release it, okay? Don't choke out and die. So just release it, okay? Yeah. Have to breathe in and breathe out, okay? Breathe out, breathe out. Don't forget to breathe out. Yeah. Here we go. So can you tell me which is the next term that we have to study in the interconversion of state of matter? Which term are we going to study later? After fusion, boiling and sublimation, which comes next? What do you think? Which comes next? Have a guess and tell me in the comment box. Yeah. You can just guess it, okay? Guess what? No worries. If it is wrong or right, really I don't care. So you have to tell me anything as you wish. Ionization, deposition, solidification, condensation, deposition, dilution. We have so many answers, but none. You are going to learn. Where is it, sir? Wait a second, okay? A second. Let me check it. Not this. Yes, definitely. None of this. The next one is freezing. Freezing. You all heard about the freezing, right? Freezing. Is this word familiar for you or you're hearing the freezing for the first time? Freezing? Freezing. I heard freezing somewhere, but really I don't know what is freezing, right? So the first thing that comes in my mind about freezing is nothing but this character. Do anyone remember who's this? Who's this? The girls are like, yes, my favorite character, and boys are like, what is this? Yeah. Who is this?
Yes.
Who is this?
Yes.
I don't know, someone is like, really, I don't care. Who is this? Yeah. Who is this? Who is this?
Disney Elsa.
Disney. The princess Elsa, right? Yeah, someone remember the snowman and ice woman, frozen Elsa? And literally everyone likes it, I guess, right? Am I right? Really? Yeah, I also like the Disney movies. So the first thing that comes in my mind when I talk about freezing is nothing but our Elsa, because she has the powers to control the freeze or the snow, right? She have a power to control all of these things. So I wish I had all those powers. I would make a beautiful world out of it. So freezing, you have to remember, not Anna, but you have to really remember about these rivers, okay? So frozen rivers, have you seen this frozen rivers anywhere? Anywhere? No? I have seen it. So I don't know if you will accept it or not, but trust me, I have seen it. But in my dreams, okay? Not in real, but in my dreams. Yeah, really. Our ma'am is like, what kind of joke was that? Yeah, really, I have seen these rivers, the frozen rivers in my dream, not anywhere else. Because I cannot go there, right? I'm in India, so I wish I will go somewhere like this, but not now. Yeah. Let it go. Yeah, someone is really singing that song over there. Can anyone sing that song for me? You can just raise your hand if you are able to sing that song. Let it go. Will anyone sing for me? Literally everyone lowered their hands. I have seen so many hand raises over there. As soon as I said to sing those songs, everyone is like, no.
I can do what I want. John is like, I can,
So-
but I won't.
Yeah, you should, John. Unmute him, sir. John,
Yes, ma'am.
can you sing that song?
I'll just close my door and then I sing.
He's just closing his door, yeah. Yeah, you may be getting scolded from your parents. Are you studying or doing something else over there? Yeah, it's all part of studies, right? We have to enjoy the moment. So, yeah, let's have a song from John.
Okay.
Yes, here we go.
Hands.
Yes.
Yeah.
Yeah.
Where do I start from? The beginning or from the chorus?
Your wish. Totally your wish.
Okay, hands.
I'm waiting. Yeah, I'm waiting. Everyone over there, I'm waiting.
Okay, let it go.
Come
Let
on.
it go, let it go. Can't hold it back anymore. Let it go, let it go. Turn away and slam the door. I don't care what they're going to say. Let the storm rage on, but the cold never bothered me anyway.
Continue it. I was literally enjoying that and you just stopped it. Very good. Very good. Yeah, I liked it, John. Thank you so much. And someone is like, ma'am, Pathan is very good movie.
And also, someone is saying Umaima is good at singing.
Umaima is good at singing. Where's Umaima? Umaima, someone is like, Umaima is good at singing. I don't know who said that,
Yeah.
but literally someone mentioned your
Is
name.
it Ritika, Neha, or Anita? You might have said it.
You have to get them next day, right?
Yeah, I know them.
Yeah, just can you sing for us? Yes, you can. Come on.
Ma'am, can you tell them to sing? I'll sing with them.
I will ask them to sing in the next day. Now it's your turn. Come on. Come on, you can do it. Yes, Umaima, I'll give you 1 second. Yeah, the 1 second is over. Come on, sing now.
Hold on a minute.
Yeah.
1 minute.
Yeah, fine. Everyone just hold on, okay? Hold on, please hold on. I thought that today we'll learn chemistry. That's right. Wait for a
So
second,
listen,
okay? We'll
John.
study chemistry. Definitely we are going to study chemistry, no worries.
John, you remind me of Ariana Grande. Grande. Yeah.
Yeah, don't make me to laugh. Anxiety, depression? No, no depression. No depression. Yeah, where is she? Umayma!
Oh, yes. Sorry, my mouth.
Come on,
Let
Umayma.
it go, let it go. Can't hold it back anymore. Let it go, let it go. Run away. What was it? I think I forgot the lyrics.
No worries. Okay, you really tried well. Thank you so much. Thank you so much. Yeah, we'll study now. Okay,
Okay,
no
yes,
worries.
thank you.
No worries. Who was that, ma'am?
Yes, it's Muhammad Suhail.
You really want to study? Yes,
Yeah.
definitely. So we were talking about what? We were talking about not the frozen but freezing, right? Freezing. So what exactly is freezing now? You all got the idea, right? What is freezing? If the river is frozen really, what happens over there? What is just happening over there? Just tell me in the comment box, what is exactly the freezing? We have learned melting, we have already learned boiling, and now coming to the freezing. Definitely, liquid into solid is called as what? Freezing, definitely. Have I asked you a question about the specific question in which state? Is that your class or I asked in any other classes? Was that you guys? No, right? So I have a question for you, okay? You already asked. Okay, moving forward. The freezing. Okay, as you can see, the liquid is just converting into solid state, okay? No. So let me ask again. So which state in this specific ocean is in? Okay, specific ocean in which state? Ask that. Alright, it is someone is like China. I won. So it is in liquid state, okay? It is in liquid state definitely. So we know that ocean, rivers are all in liquid state. If they just convert into ice, that means they are converting from liquid state into solid state. That exactly is freezing, right? So what exactly is freezing? The state of matter, the conversion of state of matter from liquid state into solid state at a specific temperature and pressure is called as freezing. Okay, freezing. Did you got it? Quickly write it down. The change of state of matter from liquid state into solid state is called as freezing. Now freezing is opposite to what? Freezing is just opposite to one thing. What is that? Is it condensation or boiling or what is it? Definitely, very good, very good. So it is just opposite to that of, let me change the color of the pen. I don't really like the red. So fusion or melting. Fusion and melting is one and the same, don't forget that, okay? So what was melting? The conversion of state of matter from solid state into liquid state was melting. Now freezing is liquid state into solid state. So they are just opposite to one another. So if you just remember what is melting, you can easily write what is freezing, right? It is just opposite to one another. So solid into liquid is melting, liquid into solid is freezing. So if you want to freeze an ice, what will we do? We will lower the temperature. Am I right? Am I right? In order to freeze something, we will lower the temperature. So in order to freeze something, we have to lower the temperature. Don't forget that too. Now, the thing that we have to study is, liquid into solid, water into ice is an example for that, okay? Keep it in fridge. Yeah, keep it in fridge. Simple. Yeah, the temperature is lower, right? Very good. What is the process of changing gas directly into solid? That is deposition. Okay, that is deposition. Deposition. We'll study that. Okay, here we go. Liquid, ma'am, glacier are example for freezing? Definitely they are. Here we go. Liquid, water into ice is an example for freezing. So now we have to study about the freezing point. We already know what is boiling point and also we know what is melting point. Now it is same with the freezing point. Only you have to change the state of matter. So what will be the freezing point? What will be the freezing point? The constant temperature at which a liquid changes into solid is called as freezing point. A constant temperature, a constant temperature. Now tell me, what was the melting point of ice? What was the melting point of ice? Melting point of ice. What was the melting point of ice? Unmute one for me, ma'am. Yeah.
Yes, of course. And let's unmute Shrita.
Shrita. Yes, Shrita. What was the melting point of ice?
The melting point of ice was 0 degrees
Was
Celsius.
0 degrees Celsius, right? Very good. So at 0 degrees Celsius, ice will convert into, that is C, okay? My handwriting, it's really weird. So ice into water. So ice into water at 0 degrees Celsius temperature, ice will convert into liquid. Okay, everyone listen to me. Listen to me. So now tell me at which temperature this water will convert into ice. Water into ice. Water into ice. So ice into water happens at 0 degrees Celsius. Now what about water into ice? Ma'am, unmute one for me.
Let's unmute Mehra.
Meher.
Mom, is it 0 degrees Celsius?
Definitely it will be 0 degrees Celsius. So what can I call that 0 degrees Celsius as?
Yes, Mehra.
Water is converting into ice and 0 degrees
Is it?
Celsius is the temperature. So what will be it?
Freezing point.
Definitely that is the freezing point of water. So freezing point of water is again 0 degrees Celsius.
Is there a different freezing point for different substance?
Definitely. This is only about the water and the ice, okay? It will vary from one substance to another. So the freezing point and the melting point is not the same for all those things, okay? It will differ. Now I'm only talking about the ice and water, okay? It will differ from one substance to another.
Can you give some examples of other substance which can convert to?
Yeah, I told you, right? I have memory issues, ma'am. Just tell him some points, okay? I'm really confused with the numbers.
Melting points.
Yes, some melting points of some compounds, alcohol.
Yes.
Yeah, the boiling point of alcohol, something like that.
Okay.
Yeah, here we go. For water, it is 0 degrees Celsius. So freezing point and melting point of ice and water, both of them are 0 degrees Celsius. At 0 degrees Celsius, ice can convert into water and water can convert into ice. Both of them are 0 degrees Celsius. And be clear with the freezing point and the melting point. What is melting point? The temperature at which a solid converts into liquid is called as melting point, and freezing point, the temperature at which a liquid converts into solid is called as the freezing point. They are just opposite to each other, okay? And both of them, the water and ice, will be having 0 degrees Celsius melting point and the freezing point. Is that clear? Is it clear? Yeah, we have the hand rises. I know what will be the question. Anyway, just ask it.
Shanit.
Who's that?
Muhammad Shanit.
Shanit. Yes, Shanit. What is your doubt?
Yes.
Shanit?
You can unmute.
Shanit?
But
Not able
we
to
are
unmute.
pushing that that
Notification, you
for-
can just unmute it. If you're not able to do that, then ask the doubt in the comment box, okay? You can ask that in the comment box. I'll see that, okay? Is that okay for you? Am I audible? What is his name?
Muhammad Shanit.
Shanit. Shanit, is that okay? Will you comment the question?
Okay, then Muhammad
Yes.
Shaheen has a doubt.
Shaheen.
Yeah, right now I just in my first class right now. I'm not understanding one thing. The melting point of ice isn't it supposed to be 100 degrees?
No, I'll explain that. Okay, is that your first class?
Yeah,
Yeah, welcome to our family. Okay.
it's
Do you have any other new students in our class? New to the class? Oh, literally, we had so many of them. I really forget to invite you to the class, okay? I'm really sorry for that. And in the middle of the session, I'm welcoming you to my class and to our family 90 plus, okay? Welcome to our family. Yes, I hope you are really enjoying the class, right? And enjoying is not enough. You had to take your notebook and write down everything, okay? You had to write down everything. Yes. Now the question he asked us, the melting point of ice is 100 degrees Celsius. No, the boiling point of water is 100 degrees Celsius. Boiling point of water is 100 degrees Celsius. So melting point is the temperature at which a solid converts into liquid. So here ice is converting into water. So the 0 degrees Celsius is the melting point. Okay, melting point. So in order to melt, they have to provide with some temperature, right? At that specific temperature is called as melting point. Okay. So melting point at 0 degrees Celsius, ice will convert into water. Now boiling point is nothing but liquid into gaseous state. So if we boil the water, it will just convert into vapor state. Am I right? Yes. So the water will just convert into liquid, will just convert into gaseous state. So the temperature at which a liquid converts into gas is called as its boiling point. Is called as its boiling point. So at 100 degrees Celsius, water will convert into its vapor state or its steam. Okay, at 100 degrees Celsius, water will convert into vapor. Okay, and freezing point at 0 degrees Celsius, water will convert into ice. Water will convert into ice. Can you please unmute him, sir, ma'am?
Okay.
Yes, ma'am. So the ice can melt into water when it is 0 degrees Celsius.
Yeah, at 0 degrees Celsius, ice can melt into water.
So what is this like? How does it make sense? Like for example, I take an ice and I take water. Sorry, I take water and we put it in the fridge and I melt it at 0 degrees. It's not melt, right? It just converts into ice form.
No, it's not like that. So at fridge, we are lowering the temperature, right? At fridge, we are lowering the temperature. So 0 degrees Celsius, we are lowering the temperature. Definitely the water will convert into ice. That's why I have told you at freezing, we have to lower the temperature. If we lower the temperature, it will convert into ice. And after 0 degrees Celsius, if we just keep this ice outside, we will increase the temperature. The temperature is just increasing. So the ice will convert into water. Okay, is it clear now?
Yeah.
Yes, fine. Very good, very good. Yes, ma'am, the next one. We have so many hand rises.
Yes, Niranjan.
Niranjan, yes, Niranjan.
Ma'am, so the melting point of the water is the same as 0 degree, right?
Yes.
So if the waters be converted into ice, would it also melt at the same time?
No, that is why I have explained right now. So if you lower the temperature, it will convert into ice. If you raise the temperature, it will just convert into water. Okay. So at 0 degrees Celsius, that is a melting and the melting and the freezing point of ice and water. So if we keep on increasing the temperature, it will convert into water. And if we keep on decreasing the temperature, it will convert into ice. Okay.
Okay.
Yeah. Now what else?
Okay, let's unmute Christy.
Christy. Yeah. My brother
Yes,
name
ma'am.
is Christy and mine is Christina. Okay. Yeah. You know that, I guess.
Yes. Ma'am,
Yes, Christy.
I'm asking, here the melting point of ice is 0 degrees and the freezing point of water is 0 degrees. So, if you keep a cup of water at 0 degrees, what's its state?
That is what I have explained, right? It is based on the temperature, okay? It is purely based on the temperature. Like if you just keep the ice in refrigerator, it will stay as ice. And if we keep in open air, it will just convert into water.
So if it's in directly 0 degree, like correct 0 degrees, then what's its state?
It exists.
Surroundings also
Yeah, the
matter.
surroundings also matter. It exists as both the water and the ice. Okay, it yeah, it definitely around this about the surroundings. We cannot determine that by not measuring the pressure and the temperature. We cannot do that. Okay, the surroundings matter. If it is in refrigerator, it will keep as ice. If we keep that outside, it will become liquid.
Yes, ma'am.
Okay, then Rishikesh.
Rishikesh,
melting
Rishikesh,
point
why
of
are
ice
you
is
keep
0
on
degree.
laughing in all the classes? I saw you laughing.
The melting point of ice is 0 degree.
Hmm.
The ice is changed into water. It will be not dangerous.
Huh? Ice into water? Is it dangerous? That was my new knowledge. I didn't thought that was dangerous to convert ice into water. It's not dangerous. How can it be dangerous? No, converting ice into water is just a physical process, right? How can be it's dangerous? No way. Yes, who else, ma'am?
Justy Thomas.
Justy. Yes, Justy.
His video is not
My doubt was clear.
Clear. Very good. So everything is clear so far, right? You can just give me a thumbs up so that I move forward with the next interconversion. Shall we? Yes. I want the thumbs ups from everyone. Not just one or two. Yes. No? Who's that, ma'am?
which one?
Telling no there in the comment.
No,
Here.
me, no. Who's that? It's Abid.
Abid. What happened, Abid?
Oh, I think Abid has a doubt.
Oh,
sorry,
okay. Sorry. We changed the page. Really
I'm
didn't
so
saw the
busy
hand
now.
rises. I'm really sorry for that. Yes, Abid.
Ma'am,
Hmm.
so when you're decreasing the temperature, it will go to negative value. -1, -2.
-2. Yeah, it will become the ice.
The freezing point is -1 or minus.
Freezing point is melting. Oh, I didn't get your question.
The freezing point of water
Is 0 degrees
-1.
Celsius.
Okay.
No, I don't think your question was clear. What was the question? Yes, Abid?
Oh, I think he's mute. Yes.
You can ask me freely, okay? I won't tell anything. Yeah. Come on. What was the topic?
If taking the contains filled with water in a fridge, the temperature will be negative.
Yeah, definitely. If we keep 1 cup of glass in refrigerator, after 0 degrees Celsius, definitely it is going to solidify. Definitely the water will convert into ice. Okay. So the temperature at which a solid converts into liquid is the freezing point. Okay. So liquid into solid is the freezing point. The temperature at that specific temperature. If we lower the temperature, it will freeze. But we want the specific temperature, right? At this temperature, it will freeze. At this temperature, it will melt. Like that. That is about the freezing and the melting point. Okay. Yes, if we just keep on decreasing or keep on increasing, it will be the same. Okay. So the freezing point and the melting point refers to the constant temperature. At that specific temperature, it will definitely going to convert. Okay. Yes, very good.
We have hand raises. Yes, Atul.
Excuse me, ma'am. So, ma'am, if 0 degrees Celsius both melting point and freezing point, ma'am, shouldn't actually be. You said that if we start decreasing the temperature from 0 degrees Celsius, then only it starts freezing.
It's not like that. It's not like that. You have to understand the concept. Okay. So here we go. With a 0 degrees Celsius, if we have a substance with a 0 degrees Celsius, if we just keep that in refrigerator, it will be converting into the solid state. Okay. It will be converting into the solid state. 0 degrees Celsius is nothing but the temperature at which they just melt and freeze. Okay. So if we just lower it, it will melt. If we just increase it, it will freeze. Okay, if we increase it, it will melt, and if we decrease it, it will freeze. Okay.
Yes.
Yes.
Yes, Daniel.
Teacher?
Yes, Daniel.
So teacher, like I just wanted to know, like without the thermometer, can we still measure the boiling point, melting point, and freezing without?
No, we don't have that powers in our hand, right? No, we cannot do that. We cannot determine, oh, the water is boiling at 100 degrees Celsius or 120 degrees Celsius. We cannot do that.
No. Can you measure it with like a different device?
Yes, we have so many other devices rather than thermometer, but thermometer is the best one for us, even though we have so many other instruments too. And rest of you students, ask the doubts in the comment box, okay? Really, I'm out of time. You can just ask in the comment box, okay? Is that clear? Will you do that? Yes, I still can see the comments, okay? So just comment it, okay? Just comment it. So unmuting one by one really takes time. So yeah, you can just comment the questions, okay? Here we go. Yeah, the freezing point. Here we go. The temperature at which a liquid converts into solid is called as freezing point. We already discussed that. Now, the thing is condensation. Condensation is the next thing that we are going to study. So, have you ever seen these things? Condensation, have you ever seen this in your windows or the car windows or aeroplane windows? Literally, someone asked me about this in the previous session. And remember who was there? And yeah, the condensation. Have you seen this? Give a thumbs up if you have seen this process. Have you seen this? No? Yeah, literally everyone did see this, I guess. Many times. Yeah, many places, many times. Yes, definitely. So this is nothing but condensation. Condensation. Now we have to learn what is exactly the condensation. You can see over here, they are water droplets, right? The water droplets got accumulated on your windows. So what is converting into liquid? Is that solid? Can you see the solid particles in the air? Definitely no. So what will be it? What will be it? It is nothing but the gases. So the gas is just converting into liquid, right? The gas is converting into liquid. That is nothing but condensation. So what is condensation? You can see the water droplets over here. There is no solid in the air. So it must be the gas. So gas is just converting into the liquid state and get deposited on the glass walls. So here we go. Not only glass walls, we can see everywhere, but specifically we can see them on the glasses. So what is condensation? Condensation is nothing but the change of state of matter from gaseous state to the liquid state at specific temperature and pressure is called as condensation. They are condensing, okay? Condensation. Gaseous state into liquid state at specific temperature and pressure. So what is the specific temperature and pressure? At low temperature and high pressure. Okay, the condensation takes place at a low temperature and high pressure. Okay, so condensation takes place at a low temperature and high pressure. So what is condensation? The change of state of matter from gaseous state into liquid state is known as condensation. So at a lower temperature in the colder regions, or in the winter season, we literally can see the condensation, because at a low temperature the gas molecules or the water vapors in the air will just convert in a liquid state into the water droplets, and they get accumulated on the things, on the surfaces of the things. Okay, that is nothing but condensation. So I hope you know what is condensation. So if you just see something like that, you have to tell everyone like it is condensation. So they will ask like, how do you know it is condensation? Have to answer, because we are the chemistry students, we know everything. Right? Yes, the condensation is nothing but gaseous state into the liquid state at a low temperature, at the lower temperature regions, and at the winter seasons we can really see this. And at a high pressure, at the mountain regions and at the high altitudes, we can see the condensation really at a high pressure. As the temperature, as the height increases, pressure also increases, right? So at a high pressure, at the hill regions, and at a lower temperature, we can really see this condensation. So condensation, so doubt in the comment box, okay? What's the temperature for the condensation? So at low temperature, okay, we cannot specify the temperature, but at a lower temperature, the gas is just converting into liquid. We have to process the clouds, right? Someone really asked that in the previous session too. I'm going to explain, okay? After this condensation and evaporation, we'll discuss about the cloud formation and the raining, okay? We'll discuss that. And ma'am, the temperature from
No, I will.
you answered already. Yes, very good. Very good. So, is the condensation clear for everyone? Is the condensation clear for everyone? Give me thumbs up. Give me thumbs up. At freezing point. No, the condensation is not at freezing point, okay? Never. Freezing point is liquid into solid is freezing point. Never ever forget about the freezing point. It is liquid into solid. It is gas into liquid now. So it cannot be the freezing point, okay? So it is condensation, gas into liquid. Yes. Ma'am, can you unmute me once? I really don't know how to. Yeah, fine. Unmute him, sir.
Who?
The bottom one, someone told me to unmute here. The second one. Yes, ma'am.
This one?
And in the second comment box, we had a comment like unmute him. No, about to that. Yeah. Just, yeah. Yes, sir. You're right. There.
Yes, I am.
Yes.
Yes,
Who
Neha.
is that?
It's Neha.
Neha. Yes, Neha.
Ma'am, I was asking that, for example, you're cooking, like you're boiling something, so you put a lid on it, right?
Lid on it.
That also you can see water droplets on the lid.
It's not like that, okay? It's not like that. So I have told you the condensation is at a low pressure. If you just put a lid on it, the water vapor will just get deposited on the walls of that plate over there or the cap. So was that your doubt? Am I
Yeah,
explaining
that
the
was
right
my
thing?
doubt. I was asking if that is also known as condensation or not.
No, it cannot be the Is it right, ma'am? Is that condensation?
Because like the vapors, it goes up and it stores on the lid.
It stores on the lid and converts into water droplets. Yeah, it can be the condensation, right? The gas state is converting into the liquid. Yes, definitely that is condensation too.
But then there is no low temperature there. There is high temperature.
But
very high temperature.
yeah, but compared to the temperature of the water, at the lid, it will be having a lower temperature, right?
Yeah.
Yeah.
Yeah, that was my doubt.
Alright. Ma'am.
Actually, I didn't hear.
Yeah, that was clear.
Okay.
Ma'am, we see the condensation in our cars, but how is that high pressure? So at low temperature, it's not like definitely in the low temperature and high pressure, it's not like that. So in the condition of low temperature or in the high pressure, this can happen. Okay. Yes. It doesn't mean both of them should be there, but at one condition also it will be taking place. Yes. And condensation, about condensation, that's it. We always do these things, right? Yeah, enjoying the small moments in our life. So we always used to do this, right? Will you do these things? Or like, we are grown up, ma'am. How can we do these things? Is it like that? No, right? So still, I do such things. So age doesn't matter. We have to enjoy everything, right? Enjoy the moment that you're living in. So do whatever you like and enjoy your life, okay? You have to enjoy your life doing such things. And if you think this little things, and when you grow up and look back into the olden times, you will find like you will be missing all these things, okay? Missing all these things that you can do in the olden ages. So do whatever you can in this age, okay? Yeah, you will really miss it. Trust me, you're going to miss everything. So enjoy every moment in your life. Here we go with the evaporation. Evaporation is very, very important, okay? Just pay attention to me. Evaporation is very, very important, okay? I'm telling this again because This is so much important for us. So evaporation, okay, evaporation. Pay attention, everyone. Listen here. Evaporation. We know that evaporation is nothing but change of state of matter from liquid into gaseous state is nothing but evaporation. It's nothing but evaporation, right? Evaporation, we already know that if we just keep a glass of water somewhere and after some time, okay, after some time, you will find like there is a decrease in the water level. Am I right? You will find like there is a decrease in the water level. Am I right or wrong? Or the water level will increase or not? The water level is going to increase, right? Is it a decrease or increase? If you just keep a glass of water in the open air or open place, after some time, after some hours, is the water still the same or increases or decreases? Yeah, answer me. Will it decrease, increase or remains the same after some time? Definitely it's going to decrease, right? Why it is decreasing? Why it is decreasing? Because evaporation is taking place. Evaporation is taking place because the water level is just decreasing just because the water is just converting into gaseous state. Converting into gaseous state. That is nothing but evaporation. Evaporation, okay? So what exactly is evaporation? The state of matter, the conversion of state of matter from liquid into gaseous state is called as evaporation. Evaporation. Okay, liquid into gaseous state is called as evaporation. Now tell me which will be the opposite thing of what? Which is the opposite of? Evaporation is opposite to what? Evaporation is opposite to what? Unmute one man.
Okay, yes, Christy.
Who's that?
Christy.
Yes, Christy.
Yes, ma'am. Condensation.
Definitely. Evaporation is just opposite to that of condensation. So if you know what is evaporation, you can really write what is condensation. So condensation and evaporation is just opposite to each other. Yes.
Yes, ma'am. So is evaporation really boiling?
No. That is what I was about to answer. Okay. About to explain. Yes. So here I have told you evaporation is just opposite to that of the condensation. What was condensation? The gaseous state into liquid state was condensation. Now evaporation, liquid state into gaseous state is called as evaporation. Now unmute one for me, ma'am.
Okay. Yes, Ishan.
Ishan. Ishan?
Ishan Muhammad.
Ishan Mohammed. Ishan? Where is Ishan?
Yes, ma'am, can you hear me now?
Yes, I can. So what was boiling, Ishan?
Ma'am, boiling is when a liquid state goes into a gaseous state at a certain temperature.
It is called boiling. Now what is
Boiling.
evaporation, Ishan?
Yes, ma'am.
What is evaporation?
Evaporation is below the boiling point.
Okay, you already knew it. So it is also the liquid into gaseous state, right?
Yes, ma'am. Yes, ma'am. Yes.
So both the boiling and evaporation, the changing of state of matter is one and the same. So listen carefully now. Boiling is what? The change of state of matter from liquid state into gaseous state was boiling. Now evaporation. Again, liquid state into gaseous state is evaporation. Now we have to learn what exactly is the difference between boiling and evaporation. We have to learn it, okay? What is the difference between, what makes it different from boiling to evaporation? What is the exact difference? We have to learn it. So what is boiling? Boiling was liquid into gas at specific temperature. That is why we have learned the boiling point. Boiling point was there, right? The boiling point. So boiling is nothing but the change of state of matter from liquid into gas at its boiling point is boiling. So without reaching the boiling point, they cannot convert into gaseous state. They cannot convert into gaseous state without the boiling point. So what is boiling? Boiling is nothing but without reaching the boiling point, they cannot convert into gaseous state. That is boiling. Okay, boiling. So what is boiling? Without reaching boiling point, they cannot convert into gaseous state. For example, water. So boiling of water, boiling of water. Okay, let's take an example of boiling of water. So if the water want to boil and convert into gaseous state, it has to reach that 100 degrees Celsius. It has to reach that boiling point. Then only the water will boil and convert into gaseous state. Okay, so that is boiling. Now talking about evaporation. Evaporation. The liquid state into gaseous state at the temperature below its boiling point is called as evaporation. So if we just keep a water in the open air, it is just evaporating. It is not boiling. Okay, it is not boiling. It is evaporating. So it is converting from liquid state into gaseous state without even reaching the boiling point. That is evaporation. Okay. So boiling, they want to reach the 100 degrees Celsius, and for evaporation, this happens below its boiling point. So don't ever forget to mention this in evaporation. The temperature below its boiling point. Temperature below its boiling point. Okay. Is that clear for you? Is that clear for you? Boiling is nothing but they have to reach the boiling point, and evaporation happens at the temperature below its boiling point. It is evaporation. Okay, and for example, in boiling, we have to provide the temperature. We have to provide them externally. Then only they will reach this 100 degrees Celsius. In order to reach this 100 degrees Celsius for water, we really have to provide the temperature. We have to raise the temperature to 100 degrees Celsius. We have to provide the heat energy. Then only the boiling will take place. Boiling takes place when we provide the temperature. Okay, we have to raise the temperature till 100 degrees Celsius. And for evaporation, it happens by itself. Okay, evaporation happens by itself, not by us. Okay, so it absorbs the temperature from the surrounding. Evaporation, they absorb the temperature from the surrounding and they just evaporate. Liquid state into gaseous state at temperature below its boiling point is called as evaporation. And did you get the difference between evaporation and boiling? Did you get it? Did you get it? Give me a thumbs up if you got what is evaporation and boiling and you understood what is the difference between boiling and evaporation. Yes, we have the hand rises over there. Yes, ma'am. You can unmute one and two for me.
Okay.
Now.
Yes, Niranjan.
Niranjan. Yes, Niranjan. And we have one more difference, okay? I will explain that.
Ma'am, is there a process where the milk is heated to a high temperature to kill the microorganism in that milk? So why doesn't the milk evaporate then?
So we are not reaching that boiling point, right? So in order to just kill the microbes, we are not just boiling them to evaporate. So if you just keep the milk over there in the stove for a long time, and when you come back into the after a few hours, you cannot see the milk over there. Can you see? The milk will evaporate, right?
Yes, ma'am.
Yes. The milk will go away if you just come after a few hours and hours back. So it will just evaporate, and for killing the microbacteria and all, we are just boiling them to a small extent, right? Then we'll turn it off. We'll not increase the temperature rather than that.
Okay.
Yes. The first one over there, ma'am.
So yes, Mohammed Shaheen.
Shaheen.
Yeah, ma'am. Is there a starting point for evaporation?
Starting point? No, it's not like that. No, there's no starting point for evaporation. It just happened. We have to study the factors too. There are some factors which is affecting the evaporation. We'll learn it, okay? It's not that there is no specific point like that. Yes, that's it, right? You got the difference between evaporation and boiling. Now, when I ask what is boiling and evaporation, you can differentiate it, right? Give me a thumbs up if you can differentiate between boiling and evaporation.
We have one more hand
Yes,
raise.
one more hand raise. Yes, ma'am.
Azalfa.
Azalfa. Yes, Asalfa.
Yes, ma'am. In evaporation, do the particles of the water do they fuse into, like in fusion? Do they intermix with the particles of the air,
Yes.
or do they become the air and gas?
It will intermix with that is called as the diffusion, right? We have discussed about the diffusion. If the water is just converting into the vapors become the gaseous state and they will just mix with the other gases over there. Okay, we cannot see it anymore. They will just diffuse into the air. Okay.
Okay.
Yes.
Okay.
I hope the boiling and the evaporation is clear for you. Now there is another thing. Okay, there is another thing for boiling and evaporation. So evaporation, water into gaseous state is evaporation. Now the thing is really the difference. Okay, evaporation was nothing but, ma'am, unmute one for me.
Okay, yes.
Not from those pages.
Which fish?
Not from these pages.
Okay, yes.
Yeah.
Yes, Ram.
Ram. Ram.
Yes, ma'am.
Ram. What was evaporation?
Evaporation is the transition from liquid state to gaseous state.
At which temperature?
At above 100 degrees Celsius.
Above 100 degrees Celsius? Ram, is that above or below? So if we just keep the water in the air like this, are you increasing the temperature than 100 degrees Celsius? Ram?
Yes.
Just think, are you increasing the temperature than 100 degrees Celsius or it is below 100 degrees Celsius?
It's below 100 degrees Celsius.
Definitely it is below its boiling point. Okay, so evaporation is below its boiling point. Don't ever forget that. Okay, evaporation happens below its boiling point. Yes. So here we go with the water. Okay, we are boiling the water and the pink color, the vapors are not pink in color, but for your better understanding I have given the pink color. Okay, yes. So here we go with the evaporation of water molecules. So the water, what's the boiling point of water? Come in, what's the boiling point of water? Boiling point of water. Quickly come in. We're out of time. Quickly come in. What's the boiling point of water? What's the boiling point of water? Quick, quick. Very good. It is nothing but 100 degrees Celsius. You can see over here, right? It is 100 degrees Celsius. 100 degrees Celsius is the boiling point of water. So at 100 degrees Celsius, the water will boil. And below 100 degrees Celsius, the water will evaporate. It's not only 25 degrees Celsius, it may be 50 degrees Celsius or 75 degrees Celsius or just 20 degrees Celsius. It will just evaporate. Okay, it is just below the boiling point, below 100 degrees Celsius. Below 100 degrees Celsius is evaporation. And evaporation is a surface phenomenon. Okay, what is it? Evaporation is a surface. It is a surface phenomenon. It's a surface phenomenon, and boiling is a bulk phenomenon. Okay, can you see the green writing over there? No, let me take the yellow. Okay, evaporation is just a surface phenomenon, whereas boiling is a bulk phenomenon. Okay, so what is the surface and bulk phenomenon means? So here we go with the evaporation first. Okay, evaporation. If we just keep the water, just imagine, okay, if you are keeping a glass of water like this in the open air, the surface water is only getting evaporated. Okay, the particles in the surface, only in the surface, the particle only in the surface is getting evaporated, not the whole thing. Okay, it is just the surface particles. Only the surface particles will evaporate. Only the surface particles will evaporate, not the other things. Okay, it is just the surface phenomenon. The particles in the surface is just converting from liquid state into gaseous state. Okay, It is just surface phenomenon because they are absorbing the heat energy from the surrounding. If they are absorbing the heat energy, the one thing that is exposed is the surface. Okay. So to the surrounding, the thing that is exposed is nothing but the surface of that water. So they are absorbing the heat energy. What happens if they absorb the heat energy? The kinetic energy of the particle increases. Kinetic energy of the particles of the surface increases. If the kinetic energy increases, they break the bond between themselves and they just evaporate. They will just convert into the gaseous state. Okay. So the thing is, evaporation, they absorb the heat energy from the surrounding, and the thing that is exposed to the surrounding is nothing but the surface of that water. Surface of that water. So the thing is, the surface particle is absorbing the heat energy. That means only the particles in the surface area is getting higher kinetic energy, not the bottom particles. Okay, they cannot get that higher kinetic energy. Only the particles in the surface is getting higher kinetic energy, and they are just converting into the gaseous state. That is evaporation. Okay, evaporation. Now what about boiling? Now what about boiling? Boiling is a bulk phenomenon. Okay, boiling is a bulk phenomenon because we are providing the temperature. We are just heating them. If we just heat it, you can see the water will boil everywhere, right? It is a constant thing. It will boil everywhere, right? So you can see the image really. Where was that image? Yeah, here. Can you see? If you just boil the water, it happens everywhere. Everywhere. You can see the bubbles, and it is called as the bulk phenomenon. It is not only in the surface, it is the bulk phenomenon. Okay. So boiling is a bulk phenomenon, not only the surface phenomenon. So that is the major difference between the boiling and the evaporation. Evaporation is just the surface phenomenon, whereas boiling, each particle will be having equal kinetic energies and they evaporate equally. They just convert into gaseous state equally. Okay. So this is a bulk phenomenon, whereas evaporation is a surface phenomenon. Okay. Is that clear for you? Is that clear? Is that clear? We have the hand raised. Yes, Daniel.
No.
No, no doubt. Yes.
Yes, Atul.
Atul. Yes, Atul.
Yes, ma'am.
Yes. Any doubts?
No, ma'am.
No.
Ma'am, I wanted to answer the question.
Answer it.
I
Very
want to
good.
know.
No worries. No worries. Yes. So who else, ma'am?
I think nobody. Yes, Christy.
Yes, Christy.
Yes, ma'am. So evaporation and boiling both are happening due to that kinetic energy.
Yes. We already learned that as the temperature increases, kinetic energy of the particle increases. If the kinetic energy of the particle increases, they move faster. If they move faster, they will break the bond between themselves. And they will, if the bond is broken, they can move freely, right? They will just convert into gaseous state. That is exactly happening in all the cases.
Okay.
Mm.
Yes, ma'am. Thank you.
Yes. That's it, right? Yes, here we go, ma'am.
Okay. It's Anaka.
Anaka, yes, Anaka.
Ma'am, I didn't understand the difference between evaporation and boiling. I understand.
After explaining that much, yeah.
Like the
Which part you didn't understand? Not at all.
no, I understood that evaporation is a surface phenomenon and boiling is a bulk. But you told something for that. And what was that? And before this, you told something else.
So if you just paid 100% attention, you could have just understood that, right? Anyway, I'll explain it again. Okay, evaporation. Evaporation. So I have told you, evaporation is a surface phenomenon. Happens only in the surface of this. Let me change the color of the pen again. Wait a second. The yellow is not clear on the white. So green. So it is in the surface phenomena. Okay. So evaporation, we are not providing any temperature. Evaporation, they takes place by them on because they are absorbing the temperature from the surrounding. Okay. And who is exposed to the surrounding? Is it the bottom particle or the surface particles? The surface is exposed to the surrounding. So if the surface is exposed to the surrounding, the particles in the surface is absorbing the temperature. Am I right? Surface, the particles in the surface is absorbing the temperature from the surrounding. That means the particles of the surface is getting higher temperature. And they are getting higher temperature. That means they are getting higher kinetic energy. Only the surface particle is getting higher kinetic energy. If they have higher kinetic energy, the particles will move around so fastly, they will break their bonds between themselves and they will just convert into gaseous state. Okay, they can freely move around, so they will just convert into gaseous state. So that happens only in the surface. So in case of boiling, we are providing the temperature from below, right? That means all the particles getting equal temperature. Okay, they are getting equal temperature. I cannot say equal, but almost they are getting the equal temperature at all the points. So they will just bubble up like that, right? I have shown you one image over there. So you can clearly see over here. So all the water molecules getting the temperature, and it is a bulk phenomena. Every particle will be having equal kinetic energy so that every particle can convert into the gaseous state. Okay, each particle, it's not only like the particles in the surface, it's not like that. Every particle can convert into gaseous state. So it is called as a bulk phenomena, not the surface phenomena. Okay, is it clear now? Yes, very good. Now, who was that, ma'am?
That's Neha.
Neha, yes, Neha.
Ma'am, so in the case of boiling, the liquid changes into its gaseous form faster than evaporation, right?
Definitely, yes.
Okay, ma'am.
So evaporation is a slow process, right? We cannot say like, yeah, I am keeping one glass of water, evaporate right now. We cannot say that. So boiling, if you just keep on boiling for 2-3 minutes, we can convert them into gaseous state. Definitely, the boiling will be faster than the evaporation. Yes, because the energy provided in the boiling is higher. That's it, right? Everyone understood about the evaporation and boiling, right? Give me a double thumbs up if you understood everything. Give me a double thumbs up. Yes, Abid.
Ma'am, in evaporation, only the surface will get evaporated, not the
not the bottom particles. Yes, not the bottom particles. They will stay there itself. But the surface particle will get evaporated. But boiling is not the case. So if they boil, the particle over here can come here, right? They're just boiling. You have the experience of boiling, right? You have seen that, right? So the particles over here can come upside and they can evaporate. Okay, if the particle is here, they can come down, and the particle over here can go up. They are just boiling randomly, right? But in the evaporation, they are just keeping like that. Okay, we are not disturbing the water, so the particle will remain here itself. The particle will not move to their positions. Okay, to the surface, it cannot move, so it will stay there. So that's it about the evaporation boil. Clear, right? Yes, so moving forward, we have a beautiful phenomenon, right? What is this? What is this picture represents? What is this picture represents? Yes. Water cycle. Very good. You have already learned all these things. Am I right? Water cycle, definitely it's the water cycle. So we learned that the water, they are just absorbing the temperature from the surrounding, and they will what? Are they boiling? Are they boiling? Here, what is this process called as? What is this arrow mark indicates? What is this arrow mark indicates? Yeah. Very good, very good. It is nothing but evaporation. It is nothing but evaporation. Very good. So change of state of matter from liquid into gaseous state below its boiling point is called as evaporation. Definitely the river, the oceans are not getting 100 degrees Celsius, right? It is just below that 100 degrees Celsius. They are just evaporating by absorbing the heat energy from the surrounding. So the first process is just evaporation. They are just evaporating into the sky. Evaporating into the sky. So we have liquid into gaseous state. We have water vapors in the air now. Water vapors in the air now. So I have told you at lower temperature and higher pressure what will happen? At higher pressure and lower temperature, what is just going to happen? Yes, very good. I'm so happy to see all those comments. Very good. It is nothing but condensation. Condensation happens. We know that the water particles are already there in the gaseous state, right? The water particles are in gaseous state. They are the water vapors. Water vapors are in gaseous state and they are already present in the air. And I have told you, as the height increases, the pressure is also increases. And you know that the sky will be having lower temperature than the land. Am I right? Yeah, you may seems like the sky is near to sun, so sky is more hotter than the land. Is anyone have that opinion? Since the sky and the atmosphere is more closer than the sky, how can be the land be more hotter than the sky? Do anyone have the opinion like that? Unmute one for me, ma'am.
Yes, we have hand raises.
Hand rises, yes. Who's that?
Ma'am,
America.
what is there anything like a gaseous state to liquid state? What is that called?
Gas into liquid?
Yeah.
That is condensation, right?
Okay. I was thinking about that.
After learning all these things, after reading Ramayana, all the Ramayana, and they will be asking like, who is Rama and Sita, ma'am? Yeah, you're asking like that. After studying all the condensation, and he's asking like, is there any way to convert gas into liquid, ma'am?
Okay.
Yes, ma'am. Unmute one.
Atul. Yes,
Ah.
Atul.
Atul. Natul, right?
Atul.
Atul.
Yes, ma'am.
Atul.
Ma'am,
Yeah. I was about to ask a
Ma'am.
question, now you are asking.
ma'am,
a
yes, ma'am.
question.
Atmosphere, ma'am. Due to pressure in the atmosphere, it's much colder than on surface.
Yes. So the question was, the land is more far away from the sun than the atmosphere of the sky. So the land will be having lower temperature than the sky, right?
Yes, ma'am.
Yes.
Ma'am, because in the condensation it is written that it occurs due to low temperature and high pressure.
So in the sky, is it low pressure or high pressure? I'm sorry, temperature.
High-
Low temperature.
Low temperature. It's low temperature but high pressure.
Low temperature. So my question is, the sky, I have told you it is low temperature, but the sky is more closer to the sun, right?
Yes. Ma'am.
So the sky must be hotter than the land, right?
No, ma'am.
No, how?
Ma'am, since
Why? Yeah, alright, going towards the next one. Why? I want to reason.
Let's ask Suraj.
Suraj, yes, Suraj. Why? I have told you, in the sky, they will be having lower temperature.
Abhinav Suraj, actually.
Lower temperature. But you can see the sky is more closer to the sun than the land. Then how come land will be having high temperature? Yeah, that's my question.
Has not.
If you just answer this question, we'll go towards the exam and we can wind up the session, okay? Until I didn't get the answer, I will not stop the class, okay?
Actually, we asked someone, but he is
Yes, not responding. Fine, ma'am. We'll go for the next one.
Okay, yes. Let's ask Felix.
Felix. Where is Felix?
Oh no.
Just disappeared.
Yeah.
Alright, Felix. We're not able to find you here. Yeah, fine. We'll go to the next one.
Yeah.
Felix is here? Yes, Felix.
Maju Felix.
Felix.
Hi, ma'am.
Hello. So, what was my question? I just melted in your hello. Yeah, the sky will be having lower temperature than the land. My question is why?
I don't have an answer for that.
You don't have the answer for that. Okay, fine.
Ma'am, because of the sun.
Because of the sun. Yeah, sun is more closer to the sky than the land.
Yeah.
Right?
Yeah.
So, sky must be having higher temperature. Why low temperature?
It depends.
Depends on what?
And
I don't know. Yeah, fine. We'll go for the next one. Who knows the answer? Here, ma'am. Ma'am, there are
Yes,
one.
yes,
The second one over there.
Rahan.
Rahan.
Yes, Rahan.
Yes, ma'am. Actually, it's lower temperature high as in higher altitudes due to low oxygen levels. There's not much carbon dioxide, which does not it does not absorb much heat over there compared to the land where there is high oxygen carbon dioxide.
It's not like that actually. But did you search something about absorption?
No, ma'am. I actually read it somewhere before about carbon dioxide levels increasing and the temperature increasing about with global warming.
Yeah, that's global warming. I'm not asking about that, okay? No, not that.
Okay, let's.
No. Global warming is another thing.
Okay. Yes.
Shall I answer it?
There are
Because
we but you can answer.
We have a lot of hand rises, but still I will answer it, okay? Because we don't have enough time. So, the thing is, the atmosphere or the gases or the particles will not absorb the air. Air will not absorb that much heat energy than the land. So the land will absorb more heat energy and they will be having higher temperature because they absorb the heat energy, but the air will not absorb the heat energy, okay? But the land will. So the land will absorb the heat energy. If they absorb the heat energy, definitely the land will be having higher temperature. Air is not absorbing the heat energy, so they will be having lower temperature, right? So always the air will be having lower temperature than the land. So my point was, in the air they will be having lower temperature. So in lower temperature and high pressure, the water droplets or the water vapors will condense into water droplets. They will convert into gaseous state into liquid state. We can say millions of tiny particles join together and they will become the cloud. So the gas particles will condense into water droplets. Okay, the water vapors, evaporation took place, right? And they just convert into water vapors that is present in the air. So that water vapors at low temperature and high pressure, they will just convert into the liquid state. So the gas particles or the water vapors will convert into water droplets. They condense together. They are tiny particles and they combine together to form the clouds. And what exactly happening in the clouds? And those water droplets, I have told you there are millions of tiny water droplets. These water droplets will join together and they become heavier and they become bigger water droplets. So the cloud cannot hold those water molecules again. So it will just pour down to the earth as rain, and the process is called as precipitation. I'm not going to talk about the precipitation right now because the only thing that we have to study is evaporation and condensation. So precipitation is just pouring the rain, pouring the water droplets into the earth or to the land and coming to the river or the oceans. It is called as the precipitation. So over here at low temperature and high pressure, the water droplets will combine together, they become heavier and they will just pour onto the land as rain, okay, as rain. It is called as the precipitation. Precipitation, okay, precipitation, it is called the rain. Okay, so yeah, wait for 2 more minutes. Okay, the precipitation. Is it clear for you? And now my question is, the rain is coming, yes, definitely, they are condensing and they are combining together and pouring as rain. What about snow? What about snow? How the snow is falling? How the snow is falling? Can anyone answer that? No. No, fine. I will answer it, okay? I can see so many hand rises over there. Still, I will answer it, okay? If I just unmute one by one, it will take time, so I will just explain it, okay? So, you don't have to study the snow anyway, just I will explain it, okay? So, low temperature. At low temperature, the gas particle will convert into liquid. And what happens even at low temperature? We are again lowering the temperature. So what will happen? The water particles is already there in the sky. So what happens if we just lower the temperature again? What happens? We have one answer over there. Very good. What about others? Can you find the answer? Yeah, at lower temperature, the water vapor converted into water droplets. And what happens if we really lower the temperature again? That's what we have learned, freezing. Am I right? It will freeze. So the water particles inside the cloud will just freeze and it will just frozen together and it will just convert into snowflakes, and that is what exactly is the snow. Okay, what is snow? So we know that condensation takes place. The water vapors will convert into water droplets at a lower temperature. If again the temperature is lower, at the Antarctica region the snow is falling, right? Because there's literally they have the lower temperature. So at that lower temperature, the water particles in the clouds will again convert into solid state. The liquid will convert into solid state at lower temperature. We know that, right? And they will just convert into snow, and that is the snowflakes. Ta-da! This is exactly called as the water cycle. Okay? And that's it. Is everything was clear? I hope everything was clear, right? Was that clear? Was the fusion, boiling, sublimation and vaporization, freezing and condensation clear for everyone? Give me thumbs up. And hand rises. Do you have time for that? No.
Clear that in the next class.
Yeah, we'll clear the doubts in the next class. Okay, really, we are running out of time. We have to attend the exam, right? So I hope literally almost everything was clear, right? Yes, very good. So that's it. We'll move towards the exam session now. Just answer the questions, okay? The exam is activated, right, sir? Yes, the exam over there is just activated. You can just attend the exam, okay? And you can save your questions for the next class. You can ask me anything, okay? In the next session, don't forget the questions, okay? Yeah, write it down somewhere else and ask me in the next session, okay? I'm waiting for that. And the online test, I hope everyone is attending that. And the first question. The phase change of a matter from liquid state to gaseous state is known as what? Liquid. Okay, don't ever get confused with so many things. The marks are recorded. Please keep that in mind. Okay, marks are recorded. Please score 10 out of 10. Okay, so liquid state into gaseous state. Liquid into gaseous state. What is liquid into gaseous state? And the next question. Which of these choices will not change the state of matter? will not change the state of matter? Is that temperature, crushing a crystal, pressure, or heat? In which phenomena water changes into water vapors below its boiling point? And the process involved the change of state from gas into liquid is called what? Yeah, that's it. If you're just done with that, let me know the scores. Okay, let me know the scores. Someone is like 10 on 10, 8 on 10,
Yes,
10,
there are a lot of 10 out of 10.
10 on 10. Very good, very good. Just let me know the score that you got. New students, are you able to do the exam? Are you able to do it? Yes, right? Yes. Ma'am, can you please unmute him? There's a hand raise over there.
Right. 3 hand raises.
3 hand raises. There, the first one.
Crystal.
Christo, yes, Christo.
Ma'am, I cannot see the exam. It's showing like no schedules.
No schedule, just refresh it. Just refresh it.
Ma'am, I refreshed.
You refreshed?
Yeah, ma'am.
Can you send a screenshot to the admin department of that?
But it is possible, I think he'll just when we leave from this meeting, can
Yeah, you can just try it again, okay? After you leave the meeting also, you can just attend the exam, okay? Just
Okay,
keep
ma'am.
on trying it. Keep on trying, okay? Refresh the page.
Is
Might
that
be
the
some
problem for
network
everyone?
trouble. Is that same for everyone? No, right? Yes.
Yes, Christy.
Yes. Christy?
Yes, ma'am. Ma'am, I did the exam, but I wanted to ask one question.
Yeah.
In this question below, there's an option known as vaporization. Is
Ah.
that same as evaporation?
Yes. Yes, definitely. Evaporation and vaporization is one and the same, okay?
Okay.
Okay. This is Daniel.
Daniel.
No, teacher, I just want to say I got 10 out of 10.
That's okay.
Very good.
Then Helmi.
Helmi. Yes, Helmi. Haven't seen you for so many days, Helmi. Where were you?
Sorry, ma'am. Ma'am, I have a doubt in the third question.
Uh-huh.
So, like in one of these, no, wait, I think, yeah, third question, in one of these, like, which of these will not change the state of matter, like, it won't separate the molecules or anything.
Yeah, the change of state of matter means liquid into gas or gas into solid or solid into liquid. That is the change of state of matter. So which of them doesn't affect them? That was the question.
Yeah.
Hmm.
Oh.
Okay.
Yes, Neha.
Neha.
Ma'am, I did not, I completed my exam and I got 10 on 10.
Very
Also, I
good.
had a doubt.
Yes.
What is precipitation? Is it the conversion of liquid into liquid?
No, it's not the conversion. Precipitation is not conversion, okay? It's just falling off from the sky to the land is precipitation. Okay, that process is called as the raining. The process of raining, snowing, that is called as the precipitation. It's not the conversions, okay?
So it is not related in the change of state of
No,
matter,
it is
right?
not at all related. It's not at all related.
Okay.
Yes, Mohammed.
Mohammed.
Yeah, ma'am. Just I have a doubt. Could you just go to the water cycle please? Yeah.
Water cycle.
Yeah, here you said that low temperature and high pressure. Isn't it supposed to be low pressure when the altitude rises?
No, in the mountains it is high pressure, right? So as the height increases, pressure is increasing.
Wait, okay.
Ah.
Okay, fine, okay.
Okay.
I thought,
I thought?
Yeah. Here's again.
Yes, Mohammed, I thought what?
oh no ma'am, I thought it was, what do you say, like, the more the altitude goes, it comes to low pressure.
No, it is high pressure. Underwater. Okay, in the oceans it is low pressure, right? Underwater it is low pressure, and at the mountains it is high pressure. So as it height increases, pressure also increases.
Okay.
And
yes, Crystal.
everyone, quickly take a screenshot of it. Quickly take a screenshot of it. Okay, everyone. Yeah, I like cheese. Quick. I hope you took the screenshot at right time. Yeah. Done? This is all the process. You can just, this is the summarized portion. You can just refer it after the class, okay? Just go to the portion, and if you have any doubt or feeling any comfortable with this diagram, just let me know in the other class, okay? In the next class, you are going to just let me know. So just take a screenshot it and write it down in your book, okay? Write it down in your book. Did you do that? Give me thumbs up. Give me thumbs up. Since someone haven't done with the exam yet, we are not going to discuss the questions, but because if we discuss the question, they will get all the answers, right? Then they will score 10 on 10. I don't want that happen. So I'm not going to discuss the questions, and we'll discuss the questions in the next session, okay? Is that fine for you? Is that fine for you? Give me thumbs up. Give me thumbs up if that's fine for you, or do you want me to explain the questions? I'll do that in the next session, okay? I hope you took down the screenshot of it. And the questions, I will discuss that in the next session, okay? Because we have some students that haven't done the exam yet, so they're trying. If we explain everything, that will be easier for them, right? I don't want to that happen. So we'll just wind up this session, okay? And doubts, just please save it for the next session, okay? Please save it for the next session. Ma'am, what is that doubt over there? Below the comment over there.
Did we complete the chapter?
Did we complete the chapter? No, it's not done yet. We have to detailedly study about the evaporation or the vaporization. We have to detailedly discuss about that. Okay, and thank you so much for listening to me, and thank you so much for studying everything literally and asking questions. Very good. Keep on interacting with me and stay tuned with the 90 plus, and I'll watch you in the next class. Until then, take care and bye bye. Good night.